Right, so what does prisoner's dilemma have to do with oligopolies? How does that work? Well, an oligopoly, as I mentioned at the end of the last video, is essentially a prisoner's dilemma scenario because, but remember with the other market structures, we have the questions, how is quantity determined and how is price determined? Well, quantity is marginal cost equals marginal revenue, and price is the market price if you're a perfect competitive, or the highest price the market can bear if you're a monopolist or monopolistically competitive. And the choice of price is going to affect marginal revenue, so the quantity decision will actually have something to do with that. With oligopolists, I mentioned that it could be either extreme. You could end up with two firms, but the outcome is basically the perfectly competitive outcome. Zero economic profit, price equals marginal cost, quantity is as high as it can be before consumers are no longer willing to pay for the costs, and it's just so allocatively beautiful. Or it could end up being the monopoly situation, where if you have two firms, it's essentially like the two firms behave as though they're two different divisions of the same company, and you produce for your half of the market, I produce for my half of the market, and we produce that lower monopoly quantity, and then we charge that nice, juicy, above average total cost monopoly price. And all the firms make a positive economic profit, we all make money, and it's beautiful. Another way of labeling these that you'll see sometimes a prisoner's dilemma is cooperate and defect. And I actually use that terminology when describing this myself. Mum and Fink is kind of a quaint way to look at actual prisoners in an actual prisoner's dilemma situation. But you cooperate with each other, you do better than you would do if you both defect. The problem is if one defects while the other cooperates, the one who cooperates is a sucker. So, in the context of two firms, first we have to define a dominant strategy. In game theory, sometimes there is no dominant strategy. Sometimes they're in pure form. There's no pure strategies equilibrium. We're going to get to that when we get to Nash equilibrium and what Nash actually talked about. And there are strategies that are strictly dominated, which means you are never going to pick it no matter what the other person does. There are max-min strategies where you try to pick what's going to cause you to lose the least, even if there's another strategy that is more likely to give you more, but there's the possibility of losing. There are ways of solving these things through various strategies. You eliminate rows and stuff. We don't actually get into that in this class. There's plenty of time for that in an intermediate class. But a dominant strategy, it is useful to know here. It's one where you really don't even care what the other firm is going to do. You're going to pick the same strategy. You care only to the extent that your payoff will be better or worse based on what the other firm does or what the other player does, but it really doesn't matter what they do. You are still best off picking one strategy. The prisoner's dilemma is one where there is one dominant strategy. So let's look at this in the standpoint of a couple of big oligopolists who there are no other firms in this market. It's just these two. And the entire market will be served by just these two. But they're different firms. They're owned by different people, and different people get to pocket the profits. So if they cooperate, if they collude, and they charge a high price, and this would be the monopoly price right here, the highest price that the market will bear, that intersects with the demand curve at a lower quantity, so your costs are lower, your prices are higher, and you get positive economic profit. Here we see that the row player, firm A, gets 40 million. The column player, firm B, gets 40 million. They've cooperated and they both get a beautiful profit. Now let's look and see what happens if they don't cooperate. If instead they charge the low price. Why would you charge a low price? Well, because your consumers know that you have the lower price. Do you want to go to the business charging a higher price when you get the same thing for less? Of course not. You're going to go to the lower price. If you charge the lower price and the other firm charges a higher price, you get the entire market coming to you. So if you charge the low price and the other firm does the same thing, zero economic profit. That's the perfect competition outcome. So obviously, you can have zero economic profit or you can have 40 million. What would you pick between these two? Well, you would pick, let's get together and charge a higher price, right? But look what happens if you're the role player and you do that. You're the role player and you say, I'm going to produce less and I'm going to charge more. And I'm going to hope that the other firm does this. But the other firm says, well, if they do that, instead of 40 million, that's 10 million extra dollars in profit. That's a big number. So, yeah, if they're going to charge a higher price, I want to charge the lower price. That's the column player's decision here. And the other firm loses -5. And the column player sees the same thing. The row player sees the same thing. Well, if they do the high price and I do the low price, my payoff is even better. So the attraction of this higher payoff and the knowledge that charging the high price that the other doesn't go along is going to mean you have to pay your cost of production, but you're not selling anything. This is why I said markets clear at the lowest possible price. You charge the high price. Over here, you charge the high price, then your market won't clear. You made stuff and you spent money to make your output, but you didn't sell any. You lost money. So this is oftentimes represented as -C, which is minus the cost of production. That's your payoff. That's lousy. So if you both charge the low price, you don't make any economic profit. But you don't lose anything either. You split the market at a higher quantity. You charge a price that's equal to marginal cost. So you're not losing anything. It's equal to average total cost, that is. So you're not losing anything, but you're not gaining anything. But you're setting yourself up so that the other firm, if they choose the high price option, you're going to make a lot of money. It's kind of hard to understand why this would be the equilibrium. This is the social optimum, clearly. This is where everybody's better off. Everybody, from the firm standpoint, wins here. You both make nice high profits. Here, it's almost like everybody loses, but this is the equilibrium. To understand why this is an equilibrium, we have to go into Nash equilibrium, and we'll get into that. But this also shows why collusion is defined as when everybody gets together. This is the collusive price, but collusion is illegal. So what we want to know is, if collusion isn't happening, how do we still see this in the market? We'll get to that. But this also explains why, since collusion is not legal, a lot of real-life situations have occurred and been observed where there are only a few dominant firms, but they charge prices that are at least close to marginal cost, and they don't make as much profit as they could if they got together. And if you study this matrix and you see what the optimal thing is, if you assume that the other firm doesn't care about you, they don't care about cooperating, they don't care about being nice to their competitors, they care about their own bottom line, about protecting themselves and maximizing their payoff, and they don't trust you, and they're seeing this same matrix, they would love it if you tried to get this juicy profit as the row player, because then they can get this big one and stick you with -5. But Nash equilibrium, this is what we were building towards. It's called Nash equilibrium in honor of Jonathan Nash, who didn't invent the idea of equilibrium. And this is where we get into that clip from A Beautiful Mind. The next video is going to be dedicated to explaining how, well, they got a lot of things wrong in that video, in that clip. A lot of things wrong in the movie overall, but it's a great movie. Anyway, we'll get to that. It's in honor of him because he discovered that there is a Nash equilibrium in every game in mixed strategies. So he didn't really invent this idea of prisoner's dilemma, though the movie makes it seem like he does. Again, we'll get to that though. But what a Nash equilibrium is, it's the best possible strategy that you can pick given what the other players picked. So you assume that if you know what the other players picked, given what they did, what's your best possible strategy? And the key test for Nash equilibrium is, do you have an incentive to unilaterally switch strategies? Can you switch strategies? Unilateral means the other players don't switch strategies, but you do. And if you do, can you be better off? If the answer is no for every single player, then that is the Nash equilibrium. You pick that strategy where there's no reason to deviate from that strategy if other players, given what other players are playing. So go back to here. Think about what the other players are doing. Low price, low price. That is the one and only Nash equilibrium outcome. You can have a Nash equilibrium given that the other player picked a different option. But if the other player picks high price, you are basically, if you're the row player and the column player decided to charge the high price here, hoping to get here, well, then you get to pick between 40 and 50 million. So, you want 40 million or you want 50 million dollars? Of the two, you're going to take 10 million extra. Again, we're assuming that there are no moral, ethical considerations. It's just rational self-interest because that's what economists do, right? So if given that firm B, the column player, picked high price, you, the row player, firm A, are better off picking low price. And there's no reason to switch because if you switch to high price, you lose 10 million. So there's no point switching from low price. And same thing for firm B, the payoffs are the same. If high price is picked by firm A, you can choose between 40 and 50. There's no reason to switch away from your low price decision. So now let's see what happens if you're both sitting here at 0. It seems like you want to switch. You would love to switch to 40, but remember, it's given what the other player is doing. So now you're the row player, and you see that the column player is picking low price. That's their choice. So now you're choosing between -5 and 0. Of those two, you want to lose $5 million or you want to lose nothing at all? Obviously, you're going to go with 0, given that the column player picked low price. The column player sees that you picked low price, they're choosing between losing 5 million or losing 0. So in both scenarios, the low price option is always the best option given what the other player has chosen. So the Beautiful Mind bar scene kind of seems to allude to the fact that Nash equilibrium, this is the Nash equilibrium, this is what we would expect to see. The Golden Balls scene, sorry about the name Golden Balls, it refers to something else, and this is not a health class or a health class for the rich, I guess. Anyway, it's a game show, and I think just about every micro class I've been associated with, both at principles and intermediate classes, and even at the advanced level when we get into game theory, anyway, shows that clip. It's just the perfect way of underscoring why the Nash equilibrium ends up being this. Because even if early on you decide to try and cooperate, as soon as someone else stabs you in the back, as happened with Sarah, you say, okay, screw it. We're doing this forevermore. Generally speaking. Now, there are some ways that you can get this outcome, but we'll get to that when we get to that. For right now, just know that we actually expect oligopolists to behave like perfect competitors, generally speaking, because of this. And so in the next video, we'll get into my rant about the Beautiful Mind scene. If you still haven't watched it, you should watch it before watching this one so you know what I'm talking about.